Before there was light, there was nothing. No time, no space, no before. Then, in a fraction of a second, everything. 13.8 billion years ago, the Big Bang. In the time it takes to blink, the universe grew from the size of an atom to the size of a galaxy, a silent, beautiful stretching of white and gold light, expanding into the infinite dark. The greatest beginning imaginable, yet it was a remarkably simple one. The early universe was just hydrogen and helium. Simple, boring, a thin, uniform soup of gas floating in an endless void. But a new force was at work, a silent, relentless sculptor of gravity. It began to pull, gathering the sparse atoms of hydrogen and helium into ever denser clouds. Over millions of years, these cosmic mists, these nebulae, grew heavier and hotter. Gravity's grip tightened, crushing the gas into scorching hot balls. And then, one by one, the first stars ignited, like a string of cosmic light bulbs switching on in a vast, dark room. The universe was no longer dark, it was filled with light. These weren't just celestial lamps, they were furnaces. Inside the crushing pressure and unimaginable heat of their cores, something truly magical happened. The simple hydrogen and helium atoms were fused together, forged into new, heavier elements. Oxygen, carbon, iron, the very building blocks of complexity. But to share these precious gifts with the cosmos, these stars had to make the ultimate sacrifice. After burning for millions of years, the most massive stars ran out of fuel. Their cores collapsed, and they detonated in the most powerful explosions the universe has ever known, supernovae. To create life, the universe had to die. These stars shattered, seeding the cosmos with the stardust that would one day become your bones and your blood. Every atom in your body, heavier than hydrogen, was forged in the heart of a dying star. We are all, quite literally, made of stardust. Fast forward about 9 billion years. We zoom into a specific, messy corner of space, our solar system. A young, energetic sun sits in the center, surrounded by a chaotic disk of leftover rock, ice, and fire. And in this swirling cosmic junkyard, gravity gets to work again. 4.6 billion years ago, a pile of this cosmic debris begins to clump together. It collides, melts, and reforms. This is Earth's infancy, but don't picture the blue marble we know today. This early Earth was a hellscape, a terrifying sphere of molten lava, with a toxic atmosphere of choking gas. It spun violently, a day lasting perhaps only 6 hours, a world entirely hostile to life. Then, catastrophe struck. Or perhaps, it was a stroke of cosmic luck, a massive object, a protoplanet the size of Mars we now call Theia, came hurtling through the young solar system on a collision course. It slammed into the young Earth. This was no gentle bump. It was an impact of unimaginable scale, a planetary-scale car crash. The collision was so violent it nearly obliterated our world. A colossal spray of molten rock and debris was blasted into orbit around Earth. Over thousands of years, gravity worked its magic once more, pulling this ring of debris together until it formed a single, spherical body. Our moon. This was a lucky collision. This titanic crash tilted our planet on its axis, giving us the seasons that drive our climate. The moon's gravitational pull stabilized that wobble and began to slow Earth's frantic rotation. It created the tides, the rhythmic ebb and flow of the oceans. Without this crash, there would be no seasons, no tides, and the Earth would spin too fast for complex life to ever take hold. The stage was being set, but the planet was still a furnace. For millions of years, Earth slowly cooled. The glowing red surface of molten lava began to harden into a dark, gray crust. But the interior was still a churning cauldron. Volcanoes erupted everywhere, covering the surface with fresh lava and, crucially, pumping enormous quantities of water vapor and other gases into the thin atmosphere. As the planet continued to cool, this steam condensed. It turned to clouds, dense, heavy, planet-engulfing clouds. And then, the rain began, not for a day, or a week, or a year. It rained for millions of years. A relentless, globe-spanning deluge that slowly filled the basins and craters, forming the first oceans. Imagine it, world of black rock under a dark sky, with endless lightning storms raging over a boiling global ocean, but this water was the magic ingredient, somewhere in these dark, turbulent, chemical-rich oceans, a new dance began. Simple chemicals, energized by lightning and volcanic vents, started to link together. They formed more complex molecules, and eventually, a molecule appeared that could do something extraordinary. It could copy itself. 3.8 billion years ago, life begins. It is small. It is silent. It is fragile. A tiny, self-replicating bubble of fat and protein drifting in the dark water. By all accounts, it's insignificant. A microscopic anomaly in a vast, violent ocean, on a small rock orbiting an average star. But it has started a chain reaction that nothing can stop. This single cell, and its descendants, will go on to transform the entire planet. They will change the chemistry of the oceans, create the very air we breathe, and evolve into every living thing that has ever existed. The initial silence of creation is over, but a new story, the long story of life itself, is about to begin. Thanks for watching MT Entertainment. Subscribe for the next part coming soon.